And all the content which we want to cover in this today's session already I have shared yesterday. And today also, once again, a few slides I share because I want to cover all this content. And hopefully the content which I share yesterday and which we cover, uh, most of you, I hope that you have gone through all this content and you tried in MATLAB using yourself, because the content which I prepared in the power presentation in the simplest way is I can make it. Okay. And I hope if you have gone through,
Pardon, sir. Yes, sir.
these are very quite simple. Uh,
Okay, you are
yeah,
the one
next
printing
one.
the result.
Gangtak, I think you have gone
Like
through
he
all
asked
this,
us to,
right?
he asked, like in our own case, he said that we should send him soft copy, he will print it himself.
Pardon? Repeat your question, please.
Forget that one.
Yes, please. You are asking some
Okay, sorry,
question?
I'm with you, sir.
Okay. So in the today's session, all the content may or may not be covered. So the thing is that there are many things for scientific computing and different type of algorithms we need to adopt. And when you have the system of equations, because there are several type of differential equations, partial differential equations, and there are several approach to simplify to get the solutions. And many times we have to adopt a numerical approach also. Okay. And the other thing, there are some solvers. Solvers are inbuilt function in the MATLAB, which we can use directly to solve the differential equations. But the thing is that first, before starting writing the code, the content which we present yesterday and one day later, for just like control statement, control flow, how we can manage. Then there are some logical operators. So logical operator, control flow, control statements, all these are very helpful to control our statements. And on the basis of these logic operator and the control statements, we can control our inputs. We can just like we can talk with the MATLAB. Okay, MATLAB only understand the instructions on the basis of these logical statement. So it is very required to understand all these logical operators as well as control statements, and also the control operators like loops, all type of loops. Okay, so you need some more experiment on this in a different way, and many examples I try to present so that the basic concept must be very clear. And related to all this, I will provide some more content so that you can use them. And after the session, I will provide some more recorded lecture. I will record and then upload. But all these will be available. Who are registered on this platform. Okay, and you can easily access all these after login your account. And I know some of the participants are facing the problem. We will discuss at the end of the session. Okay. And along with there are several solvers. There are different type of numerical methods to solve different type of models, because all type of the basic methods to solve the differential equations or partial differential equations, because there are so many problems. Okay, in physical science, in engineering, in environmental models are there, SIR model are there. So there are so many models which are applicable in medical science. Okay, for mathematical models for environmental problems. Okay, so all type of the mathematical models have different approach. So and also these days there are some like AI, artificial intelligence. We can use artificial neural network to find out the solutions of this type of problem. In each type of problem, like we have the system of differential equations or system of equations or any type of mathematical model where we can apply numerical methods. We can apply also artificial neural network to find out all these type of uh, problems, okay, which uh, may be associated with the engineering problems and physical problems or other branch of sciences. So the differential equation and partial differential equations play very important role to define all type of mathematical models, whether these are applicable in industry or business or um, in medical science or any branch of science. Okay. So the content which are included in the slides which I share with you yesterday and some slide I share today also from 5, 6, 7. Okay. These slides include some type of problems related to ODE, initial value problems and boundary value problems. And once you able to understand how we can instruct the MATLAB to write any type of differential equation or system of, in the same way, you can write a system of differential equations and system of differential equations highly useful in like SIR model. Okay, so SIR model always contain two differential equations or three, four, five, whatever depends upon the parameters, how many parameters are involved in SIR model. Okay, then there are several approaches to find out the solutions. As you know, fractional calculus is there. Okay, to find out the solutions of fractional differential equations, there are also again several techniques. We can use Laplace transform, Fourier transform is there. Okay, and numerical approach is also there. So all these models depends upon our different type of problems in which area we are working. According to that, we have to adopt the technique. But the thing is, the basic fundamentals, as you know, we start from ODE, then we can solve the problems related to PDE. Okay, then we can think about the system of differential equations and many more. So this is the only foundation lecture, how you can apply the techniques. And you know, all these methods we are not able to cover in the single lecture. In 2 hours, not possible, because many things are required. You need a lot of practice to use MATLAB, how we can give the instruction, how you can define the statement, how you can give the input of one differential equation, two differential equation, how you can apply the initial conditions or boundary conditions. Then there are some numerical methods also. Okay, how you can implement numerical methods to find out the solutions of any kind of a differential equation. Okay. So, and along with there are some, as I told in the beginning, solvers. Okay, solvers are based on numerical approach. Okay, so is on the basis of the numerical methods, some solvers are inbuilt function in the MATLAB. By using the same, we can find out the solutions. But the thing is that when you are doing some research, okay, in that case, either you have to find out or you have to develop the new technique. In that case, you should have to develop that technique or skill how you can write your own function, how you can apply the new methods, if you develop some numerical method to solve any differential equation. Then if you have the skill to write the numerical method and how you can manipulate them, then you can easily implement the same technique for your own method which you develop. Okay. And if you want to apply some physical problem for some type of model, okay, then you can use the inbuilt solvers. Okay. So all these things which are available in MATLAB or which we can create by using the MATLAB depends upon the problem. Many things are there. MATLAB itself is very huge subject, and I hope the lectures which we deliver in the last few days and today's also will help you in many more to understand all these things. And at the end, I will also provide you the feedback from form from which I need from your side. So it is time to start today's session. First of all, I would like to share my screen and yes, so this is my MATLAB and I would like to ask from you during these days, from the first day to till now, what type of problems you are facing or what do you think to about the MATLAB? Anyone can please give me some your view? I know many of the participants are very beginner and some maybe use MATLAB, but most of all of you are a very beginner. So during these 4 days after using the MATLAB, may I know some about your feedback or the use of the MATLAB? Yes, please. Anyone?
Well, this is not my first time of trying to use MATLAB.
Okay.
But basically I'm using it for to code my work. So like I did something yesterday and I noticed that after running it, it kept running. It means I don't know if there is a loop somewhere that I couldn't end it. I couldn't set a condition for it to stop. I don't know. But it kept until I had to force it to stop. So I don't know why it's like that.
Okay.
Yes, sir.
Any more? So the lectures which we deliver in the past days are helping you or not?
They are very helpful.
Very helpful.
Yes, sir.
Okay. So any more, anyone? So that I can suggest you something because this is very important to discuss with you. The content which may be covered or not, this is not the problem. Problem is that the content which we present till now, and the second thing is how you are using. Are you able to use all these or not? Are you facing some type of problem? So that we can discuss it before starting the session. Okay, this is very important. All the content will be covered. This is not the problem. I can, because during this session, the MATLAB is very friendly. Once you have the syntax, then you can use. And if I conclude the entire workshop, the thing is, main four part in the beginning, who are beginner, once you are able to understand the partition of the MATLAB, how you can, what is the purpose of command window, then how you can give your statement, how you can control the statement, then there is command history, and how you can write your script. This is a very important part, because all the things will depend upon your script. Script contain all type of coding, all type of programs, and all the programs are sequence of statements. Some are small programs, some are big programs, but depends upon how you can break the programs. Okay, if your program depends upon multiple functions which you need to define, and if you are using all these functions in the same script file, then the program will be very large. If you know how to break the function to reduce the complexity, then you will create several files, and then you will call all these functions as we do in the last lectures. As you know, we have created the function, and then we call for the numerical values. Okay, so all these things, once you able to use. And one more thing which I let you know, if you will stop, then you will forget everything. So you need to use all this consistently. You should not have the break more than 2 weeks. Okay, otherwise you will forget everything which you learn. So at least spend 1 hour or 2 hour per week, and all these will keep you update. Okay, and one more thing, all the content which we present here will be available in your account for lifetime access. Okay, if you forget, and if you think that you need to revise, and one more thing, you must download all this content. Secondly, the recording of each lecture will be available on the YouTube also. Okay. Thirdly, all the content will be available on your account where you register. Okay. And still then, if you forget or you are facing some problem, you can contact me anytime. So I hope in the today's session, there are 3 slides, okay, which I want to discuss with you. And this slide, which include symbolic summation, asymptote, critical, and inflection point, okay, which will include also maximum and minimum and value of the function, and how you can plot in the MATLAB. Then we have the simplify symbolic expression, expand function factor expression, extract. We have sub expressions from the expression, collect term, and all these are very simple functions. Just you need to use them. Okay, so here is. Yes. So here you can see we have the symbolic summation. You can see here, this is the symbolic summation. Did you try this slide? Gangtak, did you try all this? And I am also asking from the other participants.
I have not tried it.
Okay, you must, all the participants, I request you, please try all these slides in your MATLAB. Okay, and all these are very quite simple, and also all the things are clearly defined. These are the syntax where we define. Okay, and this part is the MATLAB part. So here we are using defined at this place K, a symbolic variable, and f is a function. Why we are doing this one? Because we want to calculate this value, summation k equal to 0 to 10, 1 upon k square. Okay, and there are two functions. One is SimSum function, which is inbuilt in the MATLAB. Okay, and one is sum function. And there is different use of these two functions. And see the difference at this place. Okay, so first we are creating f is equal to 1 upon k square. Okay, this is the function 1 upon k square in the summation 1 upon k square. So k is a symbolic variable, and we choose at its place k. Then there is a subs function. Sub function is to substitute the value. Okay, so the meaning of this statement is f is the function, which is 1 upon k square. K is the variable. This f function depends upon k. And we want to substitute the values from 1 to 10. These are the values 1 to 10 for k. Okay, so when you will execute this statement, this value will be generated. This value will be generated in the MATLAB. First, it will take 1, then 2, 3, 4, 5. When you have the value 1, then it will be 1. And when you will have the value of k is 2, then it will return 1 by 4. This is the value of 3. This is the value of 4, and so on. Okay. And when you will use sum, we use sum function. This will sum all the terms of the this is sequence. Okay. So by using sum, you will get the sum of the array which you have at its place. And this will return the sum of all the values. So this is the sum function, which we have the simple example. And the other, we have the SimSum. This is the SimSum function. Okay. So by using the SimSum function, we can directly get this value. We will have the direct this value by using SimSum. So this will sim means symbolic function. Okay, these are symbolic values. These are the symbolic numbers or symbolic values. So SimSum function, what will do? This will calculate or sum all the symbolic values, and is inbuilt function in the MATLAB. Okay. These are very small functions, but will be very helpful when you will write different type of programs for your own problems. Okay. So one type of, you must be very clear. The syntax is very simple. This is the f function, and this is the k. This is the first value, and this is the last value. So when you will execute this statement for this function, okay, for this function, this will return this value. And in the previous, first it will generate this vector v, and then after we will use this function. So this sum is combination of to generate the symbolic values as well as sum of the vector. So you can see both have same value. And here is also one more example. You can go through it yourself. And also sometimes if you need to calculate time, sometimes if you want to compare the time which algo is taking how much time. So what you will do to calculate the time, we have, this is one method, TIC and with the TOC. Okay, so between these two statement TIC and TOC to calculate the time, at this place you will put your program, what you have created. Sometimes when you are doing some research and you need to compare the algos, okay, which algo return first value. In that case, you need to calculate the time also while running the program. So this statement will calculate the time for the program. Okay, and between these two statements, at this place you will put your program which you write, and this is the another program. Okay, so when you will run these two statements, this will return the time, and when you will give the instruction about this these three statements, this also calculate the time to compute. So separate time for both will be available. When you will do experiment on your MATLAB, this will return the time for both the functions. And one function will take more time and other have less time. So in this way, you can compare. If you ask from me to compare, I can copy all these statement. Okay, copy and go to MATLAB. Then you can put all these statement, put the statement at this place, and here is cape. When you copy the text and some error as you can see, then always make it correct. Okay, now the file is correct. And first you need to save this file. Test. I save the file with the name of test time. And file will automatically saved in my current directory. When you will execute this file, CLC and colon clear. Okay. Now run the file. You can see MATLAB is busy. MATLAB is busy. MATLAB is calculating the values because the range is from very large. Yes. You can see this method is taking this time. Okay. And the second one, by using Simpson function, it is taking less time, only 2.868838 second. Okay. Here is 11 point something seconds. So in this way, you can calculate the time to compare different type of programs. If you develop some new technique and you need to calculate the time span also, how much time is taken by your program. So in this way, you can use the statement. Okay. Got it? Yes. You will do yourself. This is the based on summation. Here is the comparison. And the comparison is always sum and by using SimSum. These values are equal or not. Yes, these values are equal. We check in the very first example. And when you will justify both the values or the result are equal or not, then you will use the function is always. Okay, this is the first statement, or the statement by using we get the value sum function. Okay, this is the value by using the Simpson function, and this is the logical logical operator. Okay, double equal. Double equal means this is equal or not. So this will return the value logical 1. 1 means true. Okay, if the values will not be equal, then it will return 0. Got it? You got it?
Yes, sir.
Thank you. So here is Taylor series, and I hope all of you are very familiar about the Taylor series. Nothing new at this place. Just how you can define the Taylor series in MATLAB. First, you need the symbolic variable, and this is one of the function. You can choose any function. Okay, and you want to convert in the form of series. So this is the Taylor. Teller is inbuilt function in the MATLAB. We are using at this place directly. Okay. And here is F, and then you will define the order, and we put at this place 8. So when you will execute this statement, the above function will be returned in the form of a series, which you can see at this place. Okay. And series, Teller series you can define like in this way. So again, this is the same based on Maclaurin series. I let these examples for you. You will go through all this yourself. Okay, now we will discuss about this example, which is associated with the asymptotes, critical and inflection points. Okay. So why I want to target this example, because the entire this slide, which cover all these three topics, I convert it into the script file by slicing. Okay, we can slice or we can divide in the subsections in MATLAB also. See in the MATLAB. This will also help you to understand and to write how you can break different part of the program. Okay, here this is the same example which I show in the PPT. Okay, so here is this part. This part is one slice. Okay, this is the second slice, and so on. Or you can say the program is divided into subsections. Okay, so how you can do, or how you can divide the script in slices? Just you need double percentage. Okay, and at this place you will put the statement. What this section will define. Okay, so in this section I try to define the statement, which you can see here. The example describes how to analyze a simple function to find asymptote, maximum, minimum. Okay, and then we have the inflection point. So this is the function. This is the function fx is equal to 3x square plus 6x minus 1 upon x square plus x minus 3, which is this one. You can see in the PowerPoint. Okay. Then we have the same syntax for the to convert this function in the MATLAB syntax. So either you can write in the single statement, or you can divide, you can define numerator and denominator. So here this function is involved x variable. Sims x, we will define first the symbolic variable. Then this is the numerator of the function. Okay, and the syntax in MATLAB. While writing, if you are using 3x like in this way, so this is note 3 into x. The meaning of this one is 3 product x square. So you have to use at the place a product sign. Otherwise, 3x mean, if you are using only this one, 3x, this is one variable. This becomes one variable. Okay, note the product. So always keep in mind while writing the syntax, 3x square plus 6x minus 1. This is the numerator and this is the denominator. So f will be equal to numerator upon denominator. So we divide this function into part, and then we define address space. One more thing, usually in the last lecture we use EZPlot function. Okay, and EZPlot not required any range to plot. Okay, just we need to use the function inside EZPlot function in the bracket. Okay, so at that moment there was a message, we can use fplot in place of EZPlot. So now I am using here fplot. Fplot and ezplot have same function, okay? But the MATLAB, the latest version, ezplot has been replaced fplot. And along with I am using here figure 1, okay? When we have when I will run the entire file, okay, I'm running the entire code. See here. What you can see. This is figure 3. This is figure 2. Okay. Just 1 minute. This is figure 2. This is figure 2. And this is figure 1. Okay. Otherwise, we have always one figure. But here, instantly, all the plots, when you will run the code, we have at this place. Now, I would like to close. Now, if you want to plot all the images while running your entire code, and sometimes when we have the long code, because this is the one of the example for the long code. Okay, this is long programming. You can see several parts are there in this program. Okay, and different type of outputs are required on different level, and you need to visualize all the results. Okay, if you will run one part for one image, then second part for the second image, it will be very tedious. So for that, what we do, this is our first image. You will write here figure 1, okay, and plot at this place. So this will do plot for this function in this section at this place, okay. And if you want to run only this section, if you will want to run this section, then you will press at this place, okay, run section. This will return the value corresponding to only this section. See, now we have only one image because only this section run or played. Okay. Now we after that we are in the second section. Okay. Now what we are doing? To mathematically find the horizontal asymptote of f, take the limit f as x approaches to positive infinity. Okay. As x approaches to infinity, you can do like in this way, in one line statement. So for the asymptote, what we do, we will take the limit as x approaches to infinity, and we want to calculate asymptote. So now we want to run only this section. Again, you will press at this place, run the section, or you can press Control Enter. The shortcut key is Control plus Enter. You can see in the box, pop-up is there. Okay. So when you will click at this place, and you can see answer is 3. This is the asymptote and value of x. Okay. So sorry, the value of y. The value of y is x approaches to infinity. Okay. The value is 3, which is y is equal to 3. The value of y is 3. Now, to find the vertical asymptote, if you want to find out the vertical asymptote, this is the next level, because the asymptotes will be vertical and horizontal. So all type of you can calculate, and what you will do? You will do to find vertical asymptote of f, set the denominator equal to 0. Okay, and solve entering by the following. Yes, root solve denominator. So this will calculate the values, and you can run from this place. You can run this section. and you have the values. Run this section. Just 1 minute. Okay, now first you run this section and we have 3. Then after we are running this section. Okay. Okay. The problem is that we have at place a semicolon. Okay, that's why the value is not appeared in the MATLAB. Now check it. Yes, these are the values. Okay, if you want to print the value in MATLAB, then you have to remove semicolon or you need to display the value. Only then this value will be appeared in the MATLAB. Okay, so these are the roots of the above equation. Okay, now come to in the power presentation also what it is saying. We are here at this place. Yes, these are the roots. This statement is used in MATLAB. Then these are the values of x. Okay, x is equal to -1 plus root 13 upon 2 and x is equal to -1 minus root 13 upon 2. Okay, these are in the PPT, but in the MATLAB syntax, this will be in this way. So you can convert these statement, these values in this form. Okay. Then after you can see from the graph which we plotted in the first image, f has local maximum between the point x is equal to -2 and x equal to 0 and might have local minimum between x is equal to -6, x is equal to -2. Okay, and to find these maximum minimum, first what we do? For maximum minima, we need to differentiate f. Here is the function, differentiate f. Then what you will do? Simplify, because we need at this place we have the value after differentiation, but we need to simplify. And when you will simplify, when you will use this simplify function, the above expression will be reduced into in this form. Okay, and also there is pretty function. Okay, when you will use pretty function, this is the pretty function, and f1 we are using pretty function for f1. So the above expression, this one, this part will be reduced into in this form. Okay, so this is the numerator and this is the denominator, which is x square plus x minus 3 whole square. And in the numerator we have 3x square plus 16x plus 17. So sometimes this type of expression, this is the same thing, 3 minus 3x square plus 16x plus 17 upon this is the denominator. Okay, if you will use pretty function, then this expression will be converted in this form. Okay, come to MATLAB. See, so here is you can remove this semicolon. You can remove the semicolon at the place also. Okay, here is pretty f1. Okay, so we will run the step by step. So here is simplify. First run this statement. Yes, this is the same value you can see. Okay, and when you will use pretty function and run this file, the expression is converted in this way. Okay, minus 3x square plus 16x plus 17 upon x square plus x minus 3 whole square, as I have shown you in the PPT. Okay, then next set the derivative equal to 0. Okay, after taking the derivative, we need to put equal to 0 to find out the critical point. So when you will use this statement to solve, okay, so this will solve the critical points. Yes, these are the critical points. Now you can plot the maximum and minimum of f. So at this critical point, there will be minimum and minimum, and we can easily plot these values in our graph. So this is the second image, okay? But we are using for the same function. So first we will plot f function, then we are using hold on function, as you know, okay? So here you will plot these values. See, we are using here hold on, and at this place we have hold off, okay? Then double critical point, then double, you will substitute the values f critical points, okay? And this is the marker for the critical points which you get. Okay, so the critical points which you get after you using this statement will be automatically plotted by using this statement. Okay, so the points are size is double, and all these will pass through substitute. You will substitute this function. Subs is used for substitution. So the points, the values which you get for the critical points, you will pass through the function to plot. F is the function, and you want to substitute these values for the plot of the graph. Then this is the title, and you can fix the text. Okay, local minimum and local maximum. These are the range where you want to fix the value, this text. Okay, this text will appear in the image, okay, for local minimum, and this will for local maximum and hold off. So these are the syntax for the second image. So here we made two things. First, we calculate the critical point for maximum minima, and by using this statement, we will visualize in the image. See, you will run from this place. Now you will get the second image. Yes, check it. So this is the local minimum at this place, okay, and this is the local maximum at this place, okay, and you can see the corresponding value of at this place. These are the local minimum and local maximum which you can plot in the visualization. And many times when you will study for the research and various type of problems, and you need to find out the minima, maxima, and sometimes you need to plot in the image also. Okay, so these syntax will help you. Got it? Got it?
Yes, sir.
So now, inflection point, point of inflection. Can you please explain what do you mean by point of inflection? Anyone, please? Anyone? Can you please tell me about point of inflection?
Point where the function changes the concavity.
Change the continuity.
So not the concavity.
For example, okay. the point where the curve changes its concave downward to concave upward. Okay. Either convective to convexity or vice versa. So that point is the point of inflection. So here, what we do? We will do here to find the inflection, set the second derivative to 0. So we need to calculate f1 is first derivative, and here we are using diff. This will return the second derivative. Okay, then we will solve the value. We will solve this equation, and we store the value at this place, inflection underscore point. Okay, so the value will be returned, and at this place we will display the value. Okay, when you will execute this statement, you know very familiar. You are very familiar about this statement, display. Okay, so this will return, and at this place we print the value from this place. Okay. Execute these sequence of statement, and you can see there are 3 different values. Okay, but the point of inflection will be real. Only this value is real. Okay. In this example, only the first element is real number. So this is the only inflection point. The order of the root can vary. Okay. Now you can visualize this value also. You can visualize this value also, and identify the real root of the determining which root have 0 valued imaginary part. You can do by using this statement and execute the part. You have to remove this semicolon. Okay. If the semicolon is there, then the value will not return in the MATLAB. Semicolon suppress the statement. Okay. Now you have the value. And if you want to make this value pretty, you will use pretty function. You will use pretty function. Yes, this is the value. So this is the real number for point of inflection. At this place, we have the point of inflection. Now, if you want to plot the same, you can do. See, the same process is there. Same process we will adopt. We will plot. We are using here fplot function, range from -9 to 6. Okay, hold on. And this is the statement for the point of inflection. And in the previous image, we used this statement to plot the maximum minima. But here we are using for point of inflection. Okay. And this is the corresponding syntax which you want to write, and this is the plot. And when you will execute this section, you will press at this place. So this is the third image, and this is the point, very crucial point and very hard to study, the point of inflection. Okay, this is the point. So now this is the entire program to calculate all the things, and in the same manner, when you have the different type of problems and you want to write, and several examinations are there, several type of testing are required, then you can divide the entire script in this manner and will help you. Also, when you will press at this place, the entire file will execute, and you will have all the 3 graphs. See, this is the one, this is the second, this is the third. So by slicing the script file, you can easily test each part. Okay, depends upon you whether you want to run entire code or whether you want to run sub parts or subsections of the entire program. Okay. Also, there is one more thing which I should explain you. On the right hand side now, you can see here are some warnings are there. Okay. These warnings are because we are not using at this place semicolon. If you want to print this value, then use display function. You will use display function for the roots. Okay. Again, you can see now one error, one warning is reduced. You can reduce the one more warning and use at the place semicolon. This warning is also has been removed. If you want to print the value, then use display function. Okay. And here is also we need semicolon. This is the predicate function not required. Here is the warning. Use semicolon. And again, you can use semicolon. Yes, here is the warning. Now you can see there is no warning. And if it is required to print any value, then use only display function. So this is now very beautiful program which we write for testing all these critical point, okay, maxima, minima, etc. What do you need? So in this way, you can manage the file, you can write the script file, and will help you in many ways. Got it? One more thing I have skipped at this place. Yes, this is a step. Okay, if you will press this one, so this will move one by one statement. Again, press. This will be on the next statement. This will be on the next statement. Okay. So when you will press this key, this arrow sign, this will be step by step. You can see. Okay. So now we have the graph. And you can stop from this place. Sometimes you need to stop the program in between. You can press this icon. Is it clear? Is it clear?
Yes, sir.
Okay, so we have discussed here maxima, minima. All this part has been covered. Okay. All the images which you can see at this place. Simplify symbolic expression. Yes. As you know, we use a simplify function. So simplify function work for various type of symbolic expressions such as polynomial, trigonometric functions, logarithm, special functions, etc. As you can see, we have the symbolic variables at the place x and y. Okay, then simplify for 1 minus x square upon 1 plus x. Okay, there are two examples, and other is this one. This is a very long expression. At a place you can see. So when you will execute these two functions, these two statement. So after simplifying the first expression, you can see the value is x plus 1. And when you will execute corresponding to this statement, we have this value. We have this value x raised to power 12 minus 1. So by using the simplify function, you can simplify different type of expressions which are involving polynomials, trigonometric functions, logarithmic or special functions. Okay, for all type of you can use a simplify function, and we need to simplify. As you can saw in the previous program, we use this function to simplify our values. Okay, to reduce the complexity. Similarly, we can have factor expression. Sometimes you need to factorize, then you can use factor function. Here is, this is a polynomial. Okay, x cube minus 6x square plus 11x minus x. If you want to get the factor of this expression, just you need to put the value at its place and use factor function. This will return all the factors corresponding to this expression. And the factors for this expression we have is x minus 3, x minus 1, and x minus 2. Okay, so there is one more example. Sometimes we have irreducible and don't have any factor. Then in that case, this will return the same value as we give the input. You can see for this expression, there is no factor, or this is irreducible expression. Okay. Here is children function returns the sub expression of the expression. Okay. So here you can see we have the f function, and this function contain exponential function 3x, y cube, exponential 2x, y square, exponential x, y. So when you will use the children function, this will return all the sub functions, and you can see this is the first expression. This is one of the part of this one. Okay, and this is the one part of the same. So this will divide in the sub parts, sub expressions. And you can manipulate for different type of use. Collect function is also important. Sometimes you have very long expression and you want to collect the coefficient of like power. Okay, so here you can see we have, this is very long expression, and involve x y raised to power 4, x z 2x cube, and so on. Okay, very long expression. We want to collect the coefficient of x powers. Okay, so you will use collect function, and at this place we will enter expression, the all the entire polynomial which is stored in the expression. When you will execute this statement, you can see the coefficient of x cube we have is this part. Then it will return the coefficient of x square. We have yz, and coefficient of x we have this one. And at the end, the term not involving x. Okay, so this will reduce the expression in the form of x polynomial. Similarly, if you will use at its place y, then the polynomial will be in the form of y. Okay, and rest other variable will be the coefficients of each term. So by using this expression, you can easily collect whether you need to collect the coefficient of x variable or for y variable or for z variable. What you need, according to that, you can instruct, and corresponding result will be returned in the statement. Here is also one more example. Here we are collecting y. Okay, so here you can see the coefficient of y raised to power 4 we have this one. Then coefficient of y, and this is only the, these are the constant terms. Note, these are the terms not involving y. Similarly, you can use for the z expression. And sometimes, you know, we need partial fractions, and you can do by using the function which is inbuilt function in the MATLAB. The function is part frac. Okay, by using this function, you can easily make partial fractions of the expression. So here, this is the numerator, this is the numerator, and this is the denominator of some expression. Okay, and by using part frac function, and we want to get the partial fraction for this expression, which is n upon d. Okay, when you will use numerator upon, when you will use numerator upon denominator, this will be very complex expression and very hard to make partial fractions. Okay. So by using this function, you can easily, and the entire numerator and denominator are involving x. So we want to make this expression for x variable. Sometimes the expression involves some parameters also. Okay. So you have to define for what you want to make partial fractions. Okay. In the place of numerical value, suppose there are some parameters like A, B, C, D. Okay. Then also it is possible to make a partial fraction. So here you want to make a partial fraction for x. Then you will put at its place x, and as soon as you will execute these three statement, okay, and partial fraction for the corresponding and upon d, you will get this part. 1 upon x plus 1, then we have 1 upon x plus 2 square, then plus 1 upon x plus 3 cube plus 1. So this is the partial fraction of the above expression. Okay. And simplify fractions, you can use yourself this part. Don't have any big issue. Try yourself. You must try this one yourself. Yes. F11. Here is first order. Yeah, this is an important part. Here we have the syntax, how you can solve the differential equations and initial problems. Matrix method is also there. Okay. Non-linear differential equations we can solve. And boundary value problems also we can solve. Just you need to understand the syntax, and syntax are very quite simple. Okay. So here you can see this is very simple example of a first order derivative, first order differential equation. Okay. So first the thing is y depends upon t. dy upon dt means y is dependent variable and t is independent variable. You need to define this function first. Okay. So symbolic function we have is yt, and you need to define at this place. Now the thing is you need to store this differential equation in some assignment variable. Okay. So define the equation using double equal sign. See here. See, observe only this part. Observe only this part. Diff yt. This is dy upon dt from this equation. Dy upon dt, because y is function of t and diff means first order derivative of y with respect to t. This can be written as in this form. Then we are using at its place double equal. Okay. Double equal means this equal. Double equal means at its place this equal. Okay. And ty, t product y. Okay. And this differential equation has been stored in ODE. ODE. When you will execute, you can copy from this place. You can copy and check in MATLAB. Check in MATLAB. Okay. I'm using here CLC. CLC. Okay. Yes. Why this is error? Because we have to define first the expression. This one. Okay. Now you can enter this part. Okay. Yes. So see, when you will enter this statement, okay. So this is the differential equation, and this equation itself has been stored in assignment variable. This is the assignment variable. Okay, equal is assignment symbol. Okay, and this is the assignment variable, and this is the differential equation. This entire differential equation has been stored in ODE. When you will enter, this will return the value. Okay, if you will use at place semicolon, like in this way, now it will not return the value. Okay, while writing the program, we always use semicolon. Okay, now there is solve function, dsolve function. To solve the differential equation, we have dsolve function. So when you will use this dsolve function, this will return or give the solution of the differential equation. And you can see this is the syntax to solve the differential equation if you want to use in MATLAB. Once I can show you in the MATLAB. Yes, you can see. And C1 is some constant. You can see C1 is some constant is also there. And this is the solution of this very simple differential equation ODE. Okay. And you can use MATLAB to solve different type of differential equations. And these are the direct method which you can apply in MATLAB. So now come to the next example. If you have the boundary condition or you have the initial condition, you can apply the same. Suppose you have the initial condition is y0 is equal to 2. When x0 value of y is 2, this you have initial condition, and you can store this in initial condition. This is the statement to store this condition. Okay, y0 double equal to, the meaning of this one is this one, y0 is equal to 2. Sorry, at this place there will be single equal. By mistake, I use at place double equal. This is single equal. Okay, y0 is equal to 2. And this is the equation for the condition. And we will save, we want to store this first condition in some assignment variable. We are using this assignment variable is equal to y0 double equal to. So double equal is logical operator. Okay. So now we are using the same statement, but the thing is comma condition. We want to solve the equation with the condition, with the initial condition. So ODE is the differential equation which we store in this assignment variable, and then after we are using at the place condition, and when you will execute this statement, you have this answer. In the previous statement, we have at this place C1. Okay, there was some unknown value, unknown constant, but now we have 2. Okay, so when you will apply the condition x equal to 0, y equal to 2, the value of C1 is 2. So by using in this way, you can easily apply the initial condition. Got it? You got it? How you can solve the differential equation? Any
Yes,
question,
sir.
please?
Yes, sir.
Okay. Now I will speed up for all these problems because of less time. Okay. If you have the, this is non-linear differential equation. If you want to solve the non-linear differential equation with the initial condition, okay. You can see this example. We have the expression. Okay. So how you will write the left expression? First, the thing is, which I told you in the very beginning, the most important thing to use MATLAB is syntax. How you can convert any equation or any expression in the MATLAB syntax, this is very important. Okay, so here in the bracket we have dy upon dt plus y. Okay, see, diff yt, the meaning of this one is dy upon dt. Then we have plus y. Okay, and after using the bracket, we have exponent 2. Then we have equal. Equal means at this place we have double equal. And on the right hand side we have is 1. Okay, if there is some more function like any trigonometric function or exponential function, whatever you have, you can use at this place. Okay, so the entire differential equation has been stored in ODE. Okay, then we have initial condition, and this initial condition is also stored in condition. Okay, and we have the same statement. We have the same statement which we used for the previous example. Desolve ODE, comma, condition. When you will execute all these three statements, when you will execute these three statements, this will return frequently the solution of this differential equation, which will be this one. This is the solution of the above expression. This is the example for second order differential equation, and you can observe here is d2y upon dx square is equal to cos 2x minus y, and there are two initial conditions, y0 is equal to 0, y dash 0 is equal to 0. Okay, but the thing is how you can express y dash 0. Okay, for the y for y dash 0, for y dash 0 means dy 0 is equal to 0. Okay, so these are the two conditions, and these two both conditions you have to assign in the single condition. How you can make? See, so dy means diff y. Dy means diff y. Now this is the first condition. First we have to write the differential equation in the second order. Okay, check it. ODE is equal to diff yx2. Yx2 means second order derivative is equal to, then we have cos 2x minus y, and this is cos 2x minus y. Okay, now we have two conditions. This is the first condition, and the first condition will be stored in condition 1. Y0 is equal to 1. When the value of x is 0, y is 1. Okay, this is the condition 2. Now we have sorry, this is the second condition. Second means this one. Okay, just to check how you can store the first condition, second condition, and you will have the third order differential equation. Okay, you can extend according to this way. For dy, we have diff. When you have the second order, then you have to write d dy, diff y2, second order derivative. Okay, or either you can use diff for this one, and then you will pass the value. Okay, you need to assign the conditions, only then it will be possible. So you can see this is the differential equation, this is the first condition, this is the second condition in the MATLAB syntax, and then after there is one more part. At this place we are combining both the conditions, condition 1 and condition 2. Okay, condition 1 and condition 2 we can store in the single assignment variable. We are using here conditions. Okay, now we have the same statement. You can observe here is equal to desolve ODE comma conditions. Okay, but here we have two conditions, and then you will use simplify function also. Y solve is equal to simplify yx, and when you will execute this statement, you will have this solution for the above second order differential equation. Got it? You got it?
Yes, sir.
Any doubt, please? I think no doubt. Similarly, you can see at the place we have the example for third order. Now you will do yourself, okay? And see the syntax for the second order. This is the second order, okay? So it depends upon your choice how you are assigning the variable or how you are using assignment variable. So this is the corresponding code. Yes, this is the how to solve the system of differential equations. And this is the very simplest example, only two equations we have. And in the form of system of, you can have more than two differential equations. But to understand how you will implement MATLAB or how you can use MATLAB to find out the solutions of system of differential equation, and quite simple. SIR model, all the SIR models depend upon for the SIR model, there will be always a system of first order differential equations like these two equations. Okay, so this approach will be used to find out the solutions of SIR model. And this is the one of the example to use to solve one type of model. Okay, so this is the one model to solve a system of equations. So here you can see u and v are two dependent variable and t is independent. So at the place first we will define both the variables. Okay, and then after you will store this information. You can see this is the first differential equation. OD1 is equal to this is the left side diff u and double equal. This is the logical operator, and on the right hand side we have 3u plus 4v. Okay, and then this is the second differential equation is equal to, this is the second differential equation. This is the left hand side of the second differential equation, diff v. The meaning of this one is dv upon dt is equal to minus 4u plus 3v. Okay, so both the differential equations, first we need to use single assignment variable as we do in the last example for the conditions. In the same way we are using at the place. So what you see, ODE is equal to OD1, OD2. Use at the place semicolon. So when you will enter, this is the output value. Okay, so ODE odds t will be equal to, this will return odds t is equal to first equation and second equation in this way. Okay, so in this we have stored the both the differential equations. If you are using at the place semicolon, then this value will not appear in the MATLAB. Then what you will do? You will do S is equal to, you are using D-solve odds. So when you will use the D-solve odds, this will return the answer in this form. But you need to extract the value of U and V. For that purpose, you have to apply this part. Because the above the index, we need to access UT and VT from the structure S. Okay, so you will use this statement. This is the structure S. This is the structure S. Okay, so from this we need to access the value U and V. So how you can access? First you need solution for U. So this is the only just assignment variable, U solution T is equal to, you use at the place S dot U. You can use anything at the place, either UT or U1 or simply U, depends upon your choice. Okay, because we have the solution. So we are using a assignment variable at this place, u solution t. And we want to store the value of u at this place. And from what you want to access from s, you will use at this place s dot u. Then the value of u will be accessed from the above expression and will return at this place. You can see this is the solution for u, and the other solution for v. You will use v solution t is equal to s dot v. So by using these two statements, you will have the solution for u and solution for v. This is the solution for v. So from the above a system of differential equation, we have the values of u and v which are expressed at this place. So this is the value of u and this is the value of v. So in this way, you can easily use this approach to solve the system of differential equations. Please let me know if there is any doubt for you so that I can explain your doubt, your question. Yes, please. If you have any question.
Excuse, sir. Hello, sir.
Hello, good evening.
Evening, sir.
How are you?
Fine, sir.
Okay. Yes, please.
Please, sir, my question is connected to a statement you made earlier. You said because when you make a statement that if you have a long code, it may take a long time to run. But then I figured if you parallelize the code, it may improve the efficiency of the code. So what are the possible techniques that one could need to have in order to be able to parallelize a code with ease?
I don't get, sorry, I don't get your exact question. Please repeat.
Okay, you know, from your explanation, you said one of the possible reasons why if you have a long code, it may take a long time for it to run. Now, I also, from what I've read, I get to understand that you can parallelize a code. You can make it a parallel code instead of a serial one, which means that by making it parallel code, it will improve the efficiency of the code by reducing the runtime. So my question here is, okay, how can what are the possible simple techniques that one can adopt to parallelize such a code?
Can you please text me?
Okay, sir.
Yeah, please text me.
Okay, sir. Thank you.
Yes.
Thank you.
Any more question, please? The approach which now we discuss is clear to all of you? Is it fine?
Yes, sir.
Most of the participants are very silent, no questioning. Jasprit ma'am, you don't have any question? R. Kavita, Disha, Mohammad Farid. And there are many students.
Yes, sir.
Are you
Let me
putting your
start.
question?
No, actually, I need to. I understood that what you explained.
Okay,
So
okay.
for
Thank
me,
you.
it's okay. I need to. I mean, practice, huh?
Yes, yes.
So
Practice
it's
is very important, sir. Mohammad
yeah.
Farid, you are from which place?
I am from India, sir, UP. But basically, I'm working in Saudi Arabia.
Okay, great.
Yeah.
Saudi Arabia. You
Yes.
know Professor Sajid.
Yeah, he is working with me. He's my senior.
Okay, 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 great.
Yes,
Okay,
I
okay.
know.
Yeah, you are working in the same university.
Yeah, same university, sir.
Great, great. Basically, you are from UP and he is also from UP.
Yeah.
Okay. Invite me in your university.
Yeah, sure.
We will work together and contribute a lot. I will help you
Yes,
in
sir.
MATLAB, any
Yes, sir.
programming.
Yeah.
Yeah, you can use MATLAB,
Uh,
Mathematica, Maple, R, Python, whatever you need. Everything.
yeah. In my research, actually, sir. Yeah. I will contact you, sir.
Okay. So, how you came to know about this foundation?
Actually, I attached with you. I think a very long time, maybe more than 1 year. I have
Okay.
also I mean the membership from your
Great, great, great.
foundation.
Thank you.
Yes.
Thank you.
Yeah,
So, I
welcome,
think
sir.
this foundation helping you.
Yeah, sir. Yeah, I got many. I mean, many help from this one, and this type of the things is also very important nowadays. Like
Yeah.
basic MATLAB,
Yes, yes, yes,
and
yes.
also
Because there
sometimes
are,
you talk. Yes,
Hmm,
sir.
you are right. Thank you. When we have the participant like you and always motivate us. And I think by listening you, the students also will motivate
Yeah.
because they will start their career and computing play very important role in the development of science and technology these days. And when you will observe all type of development in science and technology completely depends upon computing. And for the when we are talking about computing, then some problems with the help of computer, and you need to use some software. So these days there are
Yes, sir.
several softwares like Python, Maple, Mathematica, Octave, Scilab, R programming, SPSS
Yes,
is
sir.
also there, and various type of approaches are there. Artificial intelligence also play very important role to study, to analyze various type of problems in all branches of sciences. So the
Yes, sir.
youngsters, especially students, you must adopt at least one software. Okay, once you will start to use one software, whether it is a MATLAB or Octave or Scilab or any, this will help you in many
Yes.
ways to build your future.
Yeah, yes, sir. Yeah, it is very important, sir.
Yeah, yes, sir.
So it is great. I mean that sometimes I feel that your work is really very great. And there are so many peoples they can get the benefit from you. Like
Yeah,
me also.
yes, yes, sir. I know 2 year back, in the evening, late evening, I stopped my lecture, and the timing was 7 to 9. Okay, same time, this one. So as I stop my lecture and after immediately when my lecture is over, I got a WhatsApp message And message was, thank you for your valuable lecture. So I re-message that participant. I ask, did you attend my lecture? And if possible, can you call me back? So participant called me back, and then she was a scholar actually from
Yeah.
Himachal Pradesh, Solan NIT. Okay.
Yeah.
So when she told me that all the activities which we organize at this platform, and she told that whether it was free or paid, she attend all the part, and because of these activities, she was able to start her
Yes.
research work after 1 year,
Mm-hmm. Yes.
because all the things which we present in 4 or 5 activities like LaTeX, and we started MATLAB from very basic level, as you can see in in this activity. Okay, and then
Yeah.
after that there was 4 activities more. So she take participate in 6, 7 event, and after that she was able to use MATLAB, and now she is working very smart. And sometimes when I study her paper, I really surprised
Yeah.
how she is doing in MATLAB.
Yeah.
Yeah,
Uh,
really feel and really
yes, sir.
appreciable. So by
Mm,
joining the platform, we always invite, recently we are going to start 2 faculty development program with the collaboration of Central University of Punjab, Purima University of Jaipur, Sardar Patel University, and many more. Okay, 5 institutes are
yeah.
there. One is South Africa University. So
Yeah.
in this way, we are trying to help each other how much we can support. But till
Yeah.
now, we all the things are managed by self-finance. Okay. So when the participant like you are coming with for the paid event, this type of activity really support us to manage the all type of expenses to run this foundation. Otherwise, it is very hard to manage all type
Well,
of running cost for this foundation. So
sir, very honestly, I want to tell you, sir,
yes.
I feel that your money, I mean, the cost is not much. If we see, it is very less amount. So it doesn't matter. And we take a really very effective workshop. Sometimes, like me, I did not attend your lecture. Because of the timing difference, huh?
Mhm.
So I came from the college. I mean in the evening,
Mhm.
maybe 7 after 7 o'clock in India time. Huh?
Mhm.
So this is why the beginning lecture I did not attend you. But after that, you send me all the details. I After that I see all the things.
Mhm.
Uh, then I feel that yeah, really, I got much benefit from you. And also I appreciate your hard work, sir. This is also very
uh,
important.
you
You
know,
are yeah,
for the 2 hours lecture, I have to spend at least 8 hours to prepare
yes, sir.
2 hour lecture, because many things I have to manage. I have to check all the things. Then I am able to present here. And I have more than 10 years to use MATLAB. Then I am able
Yeah,
to write all these content within 8 hours. Okay, many stuff I have, all type of stuff, but to prepare all these things. And second is, you know, you will be very surprised to know about this foundation. Last 3 years, since last 3 years, I am spending my half salary to manage all the
yeah,
expenses for this foundation
yeah.
along with my time.
Yeah.
Now 3 years are over to complete the conditions. Now we are eligible for getting some funds from government and non-government bodies, and I hope in the near future we have good funds from private sectors as well as government sector. And this will
Yes.
help to manage many things. Okay, but many things are there. This foundation is very young, established in during the COVID 2020. Okay, so first we thought to contribute to help the people, and
Yeah.
the funds we tried to manage from some type of when we have the paid activities, and this type of activity really help to manage all the expenses. Okay, and in near future when people will be very familiar about this, really, because the purpose of this foundation not to collect the money or for the business. The purpose only is
Yes.
thing to help the people to make our youngsters challengeable, or to prepare the our generation for the next generation. This is very important thing. If the our youngster have the technology, they will be very familiar to know how to use the technology, and what type of the technologies are important in the present era, and what type of the challenges are there for their future. This is very important thing
Yes.
to all the peoples. I know there are many peoples who are facing the problems. They are not able to pay even 200. This is not the big amount, but there are many people who are not able to pay this amount also. So
Yes.
that's why we are trying is easy accessible to each person, so that if any person who want to learn and that don't have money should not be the problem. The thing is,
Yeah.
the
Great.
the thing is what the student need, and can we fulfill his desire in the form of education. So education should be uh, very important for the each people from globally. Okay, there are many, we are getting many requests from different countries, mainly African countries, and there are many peoples who are not able to pay, but we are supporting them. And many times in the last 3 years, we openly organize the event for them. And whenever any person trying to contact us, we always try to give him chance to participate in the activity, whether it is free or when we have the free, then there is no problem. Whether it is paid, still then if someone is approaching to us, we never stop him to learn these things. So this
Great.
is very important if any student or participant who need this type of technology, and if we are able to help, then this help give us happiness. So we are working for
Yeah.
happiness, not for the money.
Yeah. Yeah. Great, sir. Good.
And
Thank
that
you.
is good of you, sir.
Thank
Of the
you.
truth, of the truth is that like even like me here, I think most of what I can do in MATLAB, I will credit them to you, because if you could
Yeah, I
remember, you started a tutorial sometimes in January.
hmm,
So I followed the tutorial a little, but at a point I resort to downloading them from YouTube. So I actually followed them, and they actually help. So when I noticed you post this workshop, I said, no, I will attend this workshop, because like here in Nigeria, okay, like I'm studying theoretical physics, but
yes.
then for you to be able to function well as a theorist, you have to be very good at computation. But that is what we are lacking basically in Nigeria. And that is why I figured I need to learn these things very well, so that I don't want the people coming behind me to pass through the same thing I'm going through. If I have my students, I should be able to sit them down and then put them through. Okay, this is the mathematics of your work, very good. Now, this is how you can go about the computation. I think by that, it will be of help. And that is what we're lacking. And I figured, let me just go out and look for it myself. And to be very honest, you've been very wonderful and very helpful. And I still hope to still continue partnering with you to improve my computational proficiency, because I noticed as I keep learning day in, day out, I'm improving also day in, day out. So I pray that we continue learning from you, sir. Thank you very much for your effort.
Thank you. I know when you are trying to contact me for the registration and you have many challenges. Okay. And there was numerous time communication between you and me. And at
Yes,
the
sir.
end, I thought when you will not be able to register, then I will ask you adopt this course freely. If at the moment
Thank you,
it was
sir.
possible for you, then I was I already was there was a plan for you. This will be free for you because it is very required. Because when you are trying to contact me many times, I know I did not forget. And when you approaching many time, and I thought that this course need you for your work and will be very big help. Okay. So at the end, if you will not be able to register, then this course was free available for you. But at the end, you able to register with your fees. So I thought you manage, I don't know how you manage all these things, but uh, thank you for your showing your interest in this type of activity. So now time is about to, we talk many things today and we share our thought, our feelings. This is very important to build the connectivity because connectivity is very important. I don't know whenever and where we can meet each other. And if we have the good relation as academician, student and teacher, then surely we can help in many ways each other and you can recommend. And in the new year, we are planning some course which will be free available around the globally. Okay. We are planning that with the help of one is based on MATLAB, one is based on Python because Python is free available and everyone from each place can easily access and they can use. And there are many sources these days which our generation must be very familiar and they must be trained during their schooling, their UG programs, and during their post-graduation program so that they can be able to use all these techniques for their profession and as well as they can use when they think about to start the research work also. Okay, so these tools are very important and also these tools create interest. They can especially for mathematics. Okay, mathematics, if we use these tools in mathematics for computing, then this will create interest as well as this will develop critical thinking, logical thinking, and we are familiar how you can use the application of this part. Okay, without using computing, we are not able to understand the behavior of any outcome. As you can saw that we solve the differential equation and after that you can visualize the results. This will be in the next slide, the content which I provide. There will be the visualization of the solution of the differential equations. And also you can visualize the solutions of partial differential equation or different type of mathematical model, whether it is a system of a differential equation. Okay, so by observing the solution, by studying the visualization of each solution, this will build more understanding for application in different domain. So the experiments by using this type of tools are very important for more understanding and to understand the mainly mathematics for application part. Okay, so when you are thinking to apply the mathematics which you have studied during your secondary level or UG level or PG level, then this type of will help you in many ways to apply in different domains. So this is all about the today's session. And yes, so now I would like to share with you the feedback form in the WhatsApp group. Okay. And also, if you can open your webcam for the screenshot. Can you please open your webcam for the screenshot?